Greetings everyone. I am Uday Sharma from the EEE Department of Institute of Aeronautical Engineering. Today I am going to discuss about the topic power electronics applications in electrical and hybrid vehicles. Power electronics are a key enabling technology for electrical and hybrid vehicles. It enables the efficient conversion, control, and distribution of electrical energy in these vehicles. As we know, electronics are one of the key components in any electrical based devices as they act as switches and it is used for conversion and control of the internal process happening in these electrical and hybrid vehicles. The power electronics are mostly of diodes, MOSFETs, IGBTs, etc. Power electronics is used in a variety of applications in electrical and hybrid vehicles, including such as traction control, onboard DC chargers, DC-DC converters, battery management systems, electrical air conditioning compressor, electric power steering, regenerative braking, traction control. The traction control inverter. The traction inverter is one of the most complex and important part of power electronics in the electrical vehicles. It is responsible for converting the DC power from the battery to the AC power to drive the electric motor. Mostly in the electrical vehicles, AC motors are used to drive the electrical vehicles. But the AC motors are powered by the DC batteries. So the traction inverters converts the DC supply from the battery packs to the AC supply and gives it to the AC motors. The traction inverter must be able to handle high power levels and operate efficiently over a wide range of speeds and torques. It is also important for the traction inverter to be lightweight and compact so that it does not have a significant impact on the vehicle's weight and range. As the weight increases, the range decreases. So it is necessary for any components of the electrical vehicle to be lighter. Here we can see an architecture of the EV. Firstly, the battery bank is converter is given to the DC-DC converter. The DC-DC converter is given to the traction inverter. Then it is supplied to the VCU followed by the BMS. Here the VCU is a vehicle control unit and the traction motor and battery management system can be seen here. The onboard charger. The onboard charger is responsible for converting AC power from the grid to the DC power to charge the battery pack. It is typically designed to be efficient, lightweight, so that it does not have a significant impact on vehicle's range and performance. As we have discussed earlier, anything which is placed on the air electrical vehicle should be lightweight and highly efficient. Here, the onboard charger's main role is to convert the AC power from the charging supply or regular household supplies and convert it to the DC. So the DC battery pack of the EV charges using this AC power. Some of the key design considerations for onboard chargers will be efficient possible to manage energy losses, weight and size, cost. Here, an AC to DC converter is used, which is also a power electronic device. There are multiple power electronic devices which converts the AC supply to the DC supply. Next, the DC-DC converters. The DC to DC converters are used to convert the DC voltage from the battery pack to the voltage levels required by other vehicle components such as auxiliary systems and the 12-volt battery. There are multiple other systems which uses less voltage or less powered DC supply, such as it is not necessary to send the all high DC supply to the small components such as the digital display, etc. There is a chance that the vehicle may or the digital display, the components may get damaged if we send the high DC power. So the high DC power is stepped down in some cases to send a very low DC power in the operating ranges of the digital supplies or any auxiliary systems so that they can operate. This is one of the type of power electronic device which is DC to DC converter. DC-DC converters are typically designed to be very efficient and reliable. These are also important for protecting the vehicle's electronics from damage caused by voltage spikes or fluctuations. As discussed earlier, if there is a high voltage spike, the electronics may get damaged. So, very low DC supply is provided to the electronics mostly used in the electrical vehicles. And this conversion of high DC to low DC is done by the power electronic devices such as MOSFETs, IGBTs. MOSFETs are the most common type of power electronic device used in DC-DC converters. They are relatively inexpensive and easy to manufacture. They are a good performance in efficiency and switching speed. IGBTs are also similar to MOSFETs, but they can handle high currents and voltages. IGBTs are also typically used in high power DC-DC converters, such those used in the electrical vehicles. As discussed, IGBTs are one of the preferred power electronic devices used in such cases. Battery Management System or the BMS. Battery Management System is responsible for monitoring and controlling the battery pack to ensure safe and efficient operation. It uses power electronics to control the charging and discharging of the battery pack and to protect the battery from damage. To explain this simply, here the power electronics are used in such a way that as a switch. Here, when the battery pack is going to be discharged, the power electronic switch acts as a closed. The power electronic device acts as a closed switch. Here, the battery gets charged. Once the battery is fully charged, the power electronic device acts as an open switch. So the battery gets stopped charging. As we have discussed earlier, the power electronic devices mostly act as switches in most of the cases. The BMS is also responsible for balancing the individual cells in battery pack to ensure that they all charge and discharge evenly. This helps to extend the life of a battery pack and improve its performance. Here you can see the electrical control in the BMS. We can see that the battery current, voltage, and temperature given to the safety protection, which is also a power electronic device controlled to the electrical control, which are mostly switches or electrical switches such as power electronic devices. Regenerative braking. Regenerative braking is one of the key components where power electronic devices roles are vital. The power electronics works in regenerative braking by converting the kinetic energy of the vehicle during braking back into electrical energy to recharge the battery pack. This is done using a variety of power electronic devices such as MOSFETs, IGBTs, and silicon carbon or nitride devices. Gallium nitride devices. When the driver releases the accelerated pedal or applies the brake, the electrical motor is reversed, begins to generate electricity. This electricity is used to recharge the battery pack. Generally, in any case of the electrical vehicle, the motor rotates in a particular direction by using the power of the battery pack. When the brakes are applied, or the motor starts to rotate in the opposite direction, which makes the motor to operate as a generator and produces or generates the electricity. So this generated electricity is again used to produce electricity to charge the battery. The power electronic devices in the system control the flow of current between the electrical motor and battery pack. This ensures the current flows in correct direction and the correct voltage and correct levels. As we can see, this is how the regenerative braking works. When the foot or brake pedal is done, it goes to the multiple steps such as inverter, motor, transmission system. When the accelerated is given, the power goes from in such way that from the inverter, the AC power is goes to the motor and the transmission system. But if the brake is applied, the motor acts as a generator and through the inverter, it charges the battery pack. This is how the regenerative braking works in the hybrid electrical vehicles or electrical vehicles. Here you can see how the power electronic device is used in the form of an inverter. Power electronics in an hybrid electrical vehicle. The power electronic devices used in hybrid electrical vehicles are rectifiers, inverters, and DC-DC converters. The power generated from the IC engine is three phases, but the battery packs are of DC. So this rectifier is used to change AC to DC. Inverters are used in such few cases where the front wheels are driven by the induction motor. As we can see, the engine is attached to a generator which is attached to a rectifier. This is a power electronic device. The inverter is also another power electronic device. DC-DC converter is an power electronic device. And we can see how different power electronic devices are also assembled in such a way that the hybrid electrical vehicle converts AC converts between AC and DC power to manage its efficient running. Here we can see another example of how power electronics are being controlled or being used in the hybrid electrical vehicles. Here we can see between all the components there is a power electronics controller to control all the power electronic systems such as inverters, DC-DC converters, rectifiers, etc. present in the system. Benefits of power electronics in electrical and hybrid vehicles. The usage of power electronics gives us the improved efficiency. Power electronics can help to improve the efficiency of electrical and hybrid vehicles by reducing energy losses. This can lead to increased range and improved fuel economy. Reduced emissions. Power electronics can help to reduce emissions from electrical and hybrid vehicles by improving the efficiency of powertrain. This can lead to cleaner air and a reduced impact of the environment. The power electronics can also help us in the improved performance of the electrical vehicles. Power electronics can help to improve the performance of electrical and hybrid vehicles by providing the precise control over the electric motor. This can lead to better acceleration, braking, and handling. Reduced weight and size of the power electronic devices, such as decreasing the size of the power electronic devices, can help to improve the range and increase the fuel economy and performance of a hybrid electrical vehicle or any electrical vehicle. Thank you. This is Sudesh Sharma signing off.